Hello. In this video, we are going to talk about polar coordinate system. It is an alternative coordinate system to two-dimensional Cartesian coordinate system. So, let's see first its definition. A polar coordinate system consists of the following. First, a point, which we call origin, and we represent by letter O. And second, an initial ray from the origin, which is called polar axis. So, we draw a polar coordinate system as follows. This point here is the origin, and this axis is the polar axis. Now, let's see how we sketch a point in polar coordinate system. It's a point, say P, in a polar system, a polar coordinate system, is given by an ordered pair r and theta, where these numbers are defined as follows. R is the distance between the origin and the point, and theta is the angle from the polar axis to the ray OP. Now, let's see how we sketch a general point on a polar coordinate system. So, let's take our coordinate system. Let's take a point P, given by the pair r and theta. Now, these numbers, as defined in the next board, r represents the distance between the origin and the point, and theta is the angle from the polar axis to the ray OP. Okay, before we do some examples related to polar coordinates, let me do the following remarks. First of all, and the first remark is about theta. Theta is the angle from the polar axis to the ray OP. So the angle theta has a direction, and the positive direction for theta is a counterclockwise rotation. And therefore, the negative theta will mean clockwise rotation. And second remark is about the r. From the definition, we know that the r is a distance, so it is a positive quantity. But we can extend the values of r to negative values. And to be able to do that, we have to imagine the existence of an extra ray on the left side of the origin. So we assume existence of another ray on the left side of the origin. Now, let's do another sketching where we explain those points given in the remark. So, let me have shift polar coordinate. Okay, so this is our polar coordinate system. So, if I want to sketch a negative r, or negative distance, I assume that there exists an extra ray on the left side of the origin, and I measure my distance on this axis, so this represents negative r, and if I have a negative angle, then I simply rotate in the clockwise direction, again starting from the initial ray. Okay, now we are going to solve the following exercise, and in which we are going to plot several points in polar coordinate system. So our first point will be the point 1, 0. So this is a point given in polar coordinate system. So this means that we are given the value of r, which is 1, and we are given the value of the angle theta, which is 0. So to plot this point in the polar coordinate system, we sketch our system. Then on the initial ray, we measure the distance 1 to the origin. So let's say it is, this distance here is 1. And then we rotate this distance by the angle theta in the counterclockwise direction. However, in this case, our angle is 0, which means there is no rotation. So our point 1, 0 in polar coordinate system is this point. The next question, or the next point we will sketch, is 2 pi. So this means our distance to the origin is 2. So I mark a distance of 2, and then I rotate this distance measured on the polar axis by an angle of pi in the counterclockwise direction. And I find that point. So P 2 pi is located here. Next point is the point 1 negative pi over 2. So we take our coordinate system, then we measure distance 1 on the polar axis, and we rotate this distance by an angle of pi over 2, but in the clockwise direction this time because of the minus sign. So this distance rotated in the clockwise direction, and we will find that point. This angle is negative pi over 2. That point is 1 negative pi over 2. Okay, so one last example, and we will sketch negative 1 negative pi over 4. This time, both our radius and angle is negative. So, let's take our polar coordinate system. Since the radius is negative, I'm going to measure this on the left side of the origin. So, I sketch this extra ray on the left side. I measure negative 1 on it. Then I rotate this distance by pi over 4, but in the clockwise direction. So that angle here, it is negative pi over 4, and this point here is negative 1 negative pi over 4. Next, I want to make another remark about points in polar coordinates. So, a point in polar coordinate system can be represented in more than one way. So, let me give an example to this statement. Let's consider the point 1 negative pi over 2. So, 1 means that this distance is 1, or this is 1, and our rotation is pi over 2, but in the clockwise direction. Okay. Now, if I want to express this point in a different way, I can change the direction of my rotation. For example, if I decide to rotate in the counterclockwise direction, so I choose distance 1 and I rotate this distance by in the counterclockwise direction by an angle of 3 pi over 2, and then I find the same point. Okay, now what if I want to express this point using a negative r, which means I measure the distance 1 on the left side of the origin. So here we have negative 1, and then I want to arrive to this point. For that, I need to make a rotation, let's say in, again, counterclockwise direction by an angle of pi over 2. So this same point can be also expressed as negative 1 pi over 2. Similarly, if I start again at negative 1, but this time rotate in clockwise direction, and arrive my original point, I need to make a rotation of 3 pi over 2, but since we are rotating in clockwise direction, the angle is negative. Hello. In this video, we are going to talk about the relation between polar coordinate system and Cartesian coordinate system. So, to be able to derive this relation between the coordinate systems, it's better to sketch both coordinate systems. And when we sketch them, we will sketch these two coordinate systems in a way that they are going to overlap at the origin. So this here, it's the two-dimensional Cartesian coordinate system. That point, the intersection of the axes is the origin. And I place the polar coordinate system, the origin of the polar coordinate system, on top of the origin of the Cartesian coordinate system. And I draw the polar axis of the polar coordinate system as if it's going to overlap with the positive side of the x-axis of the Cartesian coordinate system. Okay, so to be able to derive the relations between polar coordinates and Cartesian coordinates, let's take a random point. So this point is in Cartesian coordinate system is given by x and y, and let's say the same point in polar coordinate system is given by the pair r and theta. So our goal is to find relation between x, y, r, and theta. To be able to find these relations, let's show these quantities on our coordinate system. So dx is the following distance. It's the distance between the origin and the projection of the point P onto the x-axis. The y of the point P is the distance between the origin and the projection of the point P onto the y-axis. Okay, let's show r and theta on our picture. The r is the distance between the origin and the point, and the theta is the angle from the polar axis to the ray OP. Now that we have shown these quantities on our graph, on our picture, we have created a right triangle. And using that right triangle, we can derive our relations. So, in this right triangle, the x is the adjacent side of the angle theta, and y can be seen as the opposite side of the angle theta, and r is the hypotenuse of this right triangle. So, using this, we can derive easily the following relations. X is equal to r cosine theta, y is equal to r sine theta. Using the Pythagorean theorem, we have x squared plus y squared is equal to r squared. And finally, tangent theta is equal to y over x. In this exercise, we are going to see how to change polar coordinates into Cartesian coordinates using the relations we have just derived. So the question clearly states that what we are given are the polar coordinates of the point. So square root of 2 is r, and pi over 4 is the theta. And our goal is to find the x and the y. And we do that by using the relations that we have just derived. X is equal to r cosine theta. So square root of 2 cosine of pi over 4, which is square root of 2 times 1 over square root of 2, which is 1. And the y is r sine theta. So square root of 2 sine pi over 4, which is again square root of 2 times 1 over square root of 2, which we find again 1. So P is given by 1, 1 in Cartesian coordinates. In this exercise, we are going to find polar coordinates of a point which is given in Cartesian coordinates. So our point in Cartesian coordinates is square root of 3, negative 3. So those are the x and the y components of the point. And we want to find the corresponding r and theta where r is positive and theta is negative. So from the relations, we have r squared equals x squared plus y squared. So then we find square root of 3 squared is 3 plus negative 3 squared, which is 9. So we find r squared to be 12. Then we know that we are looking for a positive r. So we solve this equation for r and we find that r is equal to 2 square root of 3. So next we find theta, and to find theta we use the relation that tangent theta is equal to y over x. Then using the values of x and y, we find that tangent theta is equal to negative square root of 3. So we observe that tangent theta is negative. So this means that theta is either in the second quadrant or in the fourth quadrant. And to be able to make a correct choice for theta, it's better we find the location of this point on the plane. So here we sketch Cartesian coordinate system. We locate our point, square root of 3, negative 3. That's where our point is. And to be able to reach that point by rotating, starting at positive side of the x-axis, we observe that we need to make a rotation of an angle in the fourth quadrant. So we are going to solve this tangent theta equation for an angle in the fourth quadrant. Now we observe from this picture that theta has to be in the fourth quadrant. Therefore, theta is 5 pi over 3. The question is not over yet because the question wants from us a negative angle. So what we have found is the following. We have described this point using a positive r and a positive angle. So 5 pi over 3 corresponds to this rotation. But since we want a negative angle, which means a clockwise rotation, we need to calculate this angle here, and which is, from the picture, negative pi over 3. So since theta has to be negative, we take for theta negative pi over 3. So the point P in polar coordinates is 2 square root of 3 negative pi over 3. Hello. In this video, we are going to talk about polar equations and graphing polar curves. So, let us start with some definitions. A polar equation whose general form can be given like this is a relation between r and theta. Okay, now graph of a polar equation is collection of points given in polar coordinates P, r, and theta that satisfy the equation the polar equation okay, and we call the graph of a polar equation polar curve. In the rest of this section, we are going to talk about how to sketch polar curves. In this exercise, we are going to show you how to express a polar equation in Cartesian coordinate system. So, we have seen previously the relation between Cartesian coordinate system and the polar coordinate system. Before I start this exercise, I want to remind you those relations. So, we recall that the x is equal to r times cosine theta, y is equal to r sine theta, and x squared plus y squared equals r squared, and tangent theta is equal to y over x. Now, using those relations, we can convert polar equations into Cartesian equations, or vice versa, Cartesian equations into polar equations. So, let's see our examples. So, first, we want to change this Cartesian equation y equals 7 into a polar equation. All we have to do is express y in terms of r and theta. So y is r sine theta, that is equal to 7. And we can rewrite this equation also in the form of y over r equals 7 over sine theta, which is 7 cosecant theta. So, another example would be to change the Cartesian equation x equals 2 into polar equations. Then we know the expression of x in polar coordinates. It is r cosine theta. So this is equal to 2. And then we can rewrite this equation as r equals 2 over cosine theta which is 2 secant theta. X times y is equal to 1. So we follow the same procedure. X is r cosine theta, y is r sine theta, and all this is equal to 1. So we simplify this expression. R squared is equal to cosine theta sine theta, and that's equal to 1. And then we can also rewrite this as r squared is equal to 1 over cosine theta sine theta, which can be simplified to r squared equals secant theta times cosecant theta. Now let's have a look at the Cartesian equation x squared plus y squared equals 1. We have an expression for x squared plus y squared from our relations that is equal to r squared. So the equivalent polar equation for this x squared plus y squared equals 1 is r squared equals 1. Now our last example is going to be y equals x squared. So write for y r equals sine theta, and for x r times cosine theta. Then we simplify this. So r is equal to sine theta over cosine squared theta. Okay, this is enough, but we can simplify this further. So sine theta over cosine theta times 1 over cosine theta, which is equal to r equals tangent theta times secant theta. In this exercise, we are going to find equivalent Cartesian equations for the given polar equations, and then we will identify them. Our first example is the polar equation r equals 3. Now, if we square both sides of this equation, we are going to obtain r squared is equal to 9. Then we know how to express the r in terms of x and y. It is x squared plus y squared. So that is equal to 9. So this is our equivalent Cartesian equation. Now we can identify this equation as this is a circle with radius 3 and center at the origin. Next, we look at the polar equation theta equals pi over 4. Now, I apply tangent to both sides of this equation, and it gives us that tangent theta is equal to 1, and then we know the expression of tangent theta in terms of y and x. It is y over x, so that is equal to 1, and by rewriting it, we find the equation, the Cartesian equation, y equals x. Okay, now for the identity of this Cartesian equation, it is a line through the origin with slope 1. Okay, our next equation is r equals 4 sine theta. To change this into an equation in Cartesian coordinates, I multiply both sides of the equation by r. Then I substitute for r squared, x squared plus y squared, and for the r sine theta, the y. Now, this is an equivalent, this is a Cartesian equation which is equivalent to this polar equation. So, which means that as a solution it is enough. However, in order to identify this Cartesian equation, we have to rewrite this in a different form. So, we continue. To rewrite this equation. Now, I have two terms with y on the left-hand side. So I'm going to add a certain constant in order to complete these two terms into a square, into a parenthesis square. So, and the constant that we need for this is 4. So I add 4 on both sides. And then I group the last three terms into parenthesis square. And I rewrite my Cartesian equation in this form. Now, using this form, we can easily identify this equation. This is again a circle, but with radius 2 and center at 0, 2. Our last example will be r equals 9 cosine theta. For this exercise, I follow the same steps as the previous one. I multiply both sides by r. Then I substitute for r squared, x squared plus y squared, and I substitute for r cosine theta dx. This is a Cartesian equation, but in order to identify it, we need to rewrite it. X squared minus 9x plus y squared is equal to 0. To complete the first two terms into a parenthesis square, we need a constant. X squared minus 9x plus 81 over 4 plus y squared is equal to 81 over 4. So the constant that we need is 81 over 4. How do we find this constant? We divide the coefficient of x into half and we square it. And that's the number which has to be added on both sides. Then the first three terms can be written as the parenthesis squared of x minus 9 over 2. And we have y squared, and all this is equal to 81 over 4. So now in this form, the equation is easy to identify. This is again a circle with radius 9 over 2 and center 9 over 2, 0. Now we are going to discuss how to sketch polar curves. We are going to talk about three methods of sketching. They are the following. First, we will sketch polar curves by finding their Cartesian equations. Second method will be by plotting points. And the third point, or the third method, is going to be by sketching in Cartesian coordinates the polar curve. This exercise is going to illustrate the first method of sketching, which is by finding Cartesian equation. So, in this exercise, we are given a polar equation, r equals 4 over sine theta minus 2 cosine theta. We are going to first change this into Cartesian coordinates. So to do so, I rewrite this polar equation as follows: r sine theta minus 2r cosine theta is equal to 4. And then I substitute for r sine theta the y, and I substitute for r cosine theta dx. So, an equivalent Cartesian equation to this polar equation is y minus 2x equals 4. Now, we can identify this Cartesian equation as a line. And we can easily sketch this line we draw here the Cartesian coordinate system. Then we find the y and x intercepts of this line. So the y-intercept is 4, and the x-intercept is minus 2. So this is a line which passes through the points -2, 0, and 0, 4. And that's the graph of this polar equation. In this exercise, we are going to illustrate the second method of sketching polar curves. We are given the polar equation r equals 2 sine theta. And to sketch this equation, we need to calculate some points on this polar equation. And to do that, we create a table. Excuse me, here is R. And this column is for R, and this column is for theta. We substitute some values for theta. And for these values of theta, we evaluate the r using the polar equation. So when theta is 0, r is equal to 2. When theta is pi over 2, r is 3. At pi, r is 2 again. At 3 pi over 2, r is 1. And at 2 pi, r is again 2. Now that we have created this table, we can read the points which corresponds to those values. So let me write here the points. So to the value theta equals 0 and r equals 2 corresponds the point 2, 0. And next we have the point 3 pi over 2, 2 pi, 1, 3 pi over 2, and 2, 2 pi. So with the help of this table, we have found some points which are on this polar curve. Now we plot these points on the polar coordinate system. The point 2, 0. So we measure the distance 2 to the origin, and then we rotate that distance by an angle of 0, which means no rotation. So the point 2, 0 is here. Then our next point is 3 pi over 2. So we measure distance of 3 and then rotate this by pi over 2, which we are going to find point here. So 3 pi over 2. So before moving on to the third point, let us connect these 2 points. So these 2 points are going to be connected by an arc which rotates in the counterclockwise direction. The reason for counterclockwise direction is because the positive direction in polar coordinate system is counterclockwise direction. So I connect these 2 points using an arc which rotates in the counterclockwise direction. Then we move on to the third point, which is 2 pi. So the distance 2 is rotated by an angle of pi in the counterclockwise direction, and we come to that point. And before moving on to the next point, we connect this point with the previous point using an arc in the counterclockwise direction. And we move on to the next point now, which is 3 pi over 2. So the distance 1 rotated by an angle of 3 pi over 2, we find that point. And that point is connected to the previous point by an arc which rotates in the counterclockwise direction. And our last point on the table is 2 pi. So distance 2 rotated by 2 pi. We are back to our initial point. And we connect this point to our last point by an arc in the counterclockwise direction, and we get our sketch. To illustrate the third and the last method of sketching, we are going to look at the polar equation r equals 1 minus cosine theta. So, in this method, we need to sketch the polar equation in Cartesian coordinate system. So I have here 2 x's. The horizontal one is theta and the vertical one is r. This coordinate system, I sketch the curve, the equation r equals 1 minus cosine theta. So its curve is this. Now let's mark some important points on this curve. First of all, this curve is going to give us 1 when theta is equal to pi over 2. As you see, when theta is equal to 0, r is 0. Then it will give us 2 when theta is pi. It will give us again 1 when theta is 3 pi over 2, and at 2 pi we will find again 0 for r. So this is the sketch of the equation r equals 1 minus cosine theta in Cartesian coordinate system. Now we transfer this sketch into polar coordinate system. I'm going to divide this sketch into different regions. So the first region is the region where thetas are from 0 to pi over 2. Then the region from pi over 2 to pi is the second region. The region from pi to 3 pi over 2 is the third. And from 3 pi over 2 to 2 pi is the fourth region. Now, for the first region, we observe that the r's start at 0 and increase to 1. And pi over 2, they become 1. So we start at the origin, because this is the place where r's are 0. And then we increase to r equals 1, and r's become 1 at pi over 2. So this piece corresponds to the region 1. And for region 2, we observe that the r's continue to increase. They increase from 1 to 2. And at pi, they become equal to 2. So the pi is on this axis. So I'm going to increase up to 2, and it becomes equal to 2 at pi. And this arc corresponds to the second region in our Cartesian graph. The third region, we observe that r's start to decrease. At pi, they are 2, they decrease, and at 3 pi over 2, they become 1. So, start here, and we decrease down to 1, and it becomes 1 at 3 pi over 2. And this piece, this arc corresponds to the third region in Cartesian graph. Now, the fourth region, the r's still decreasing from 1 to 0, and that will correspond to this arc in polar equation. And this completes our sketch. Hello. In this video, we are going to talk about tangents to polar curves. Now, to be able to talk about this, we first need to explain you how to find the slope of a tangent line to a polar curve. So, let's have a polar curve of the form r equals f of theta. Then the slope of the tangent line to the polar curve r equals f of theta at theta equals alpha is given by the formula so at theta equals alpha, dr over d theta times sine theta plus r cosine theta all over dr over d theta cosine theta minus r sine theta, where we evaluate this formula at theta equals alpha. Now, again, let me box this formula. Now, before we do an application of this formula, I want to say a few words about the origin of this formula. Now, recall that we can see a polar curve which is of the form r equals f of theta as a parametric curve where the parameter is theta as follows. So we remember the relation between the Cartesian coordinates and the polar coordinates. So x is equal to r cosine theta and y is equal to r sine theta. And we substitute the expression of r in terms of theta, which is f of theta, in both relations. Okay. Now, we also recall the slope of the tangent line to the parametric curve let's say given by x equals g of t and y equals h of t at the parameter t equals a is dy over dx at t equals a is equal to derivative of y with respect to t all over derivative of x with respect to t. And all is evaluated at a. Now, to obtain our formula here in the box, we are going to combine these two facts. So, I'm going to derive these relations in terms of theta with respect to theta. So, first of all, let's find dy over d theta. So, we get dr over d theta sine theta plus r cosine theta, and dx over d theta is dr over d theta cosine theta minus r sine theta. And here, dr over d theta is in fact derivative of f with respect to theta. Okay, then dy over dx is equal to, like here, it's dy over d theta over dx over d theta. which means that we should take the quotient of these two expressions. So we get the r over d theta sine theta plus r cosine theta all over the r over d theta cosine theta minus r sine theta. Now, if we evaluate this at theta equals alpha, we will get the slope formula which we have shown in this red box. As an application to the slope of a tangent line, we are going to solve the following question. We'd like to find the slope of the tangent line to the polar curve r equals 1 plus 2 cosine theta at theta equals pi over 3. So our formula is here. So we need to calculate first the derivative of r with respect to theta, and then we will put it in this formula. So the r over d theta is minus 2 sine theta. Okay? Now let's put this in our slope formula. Minus 2 sine theta times sine theta plus r, 1 plus 2 cosine theta times cosine theta all over the r over d theta, which is minus 2 sine theta times cosine theta, and minus r, which is again 1 plus 2 cosine theta times sine theta. And then we are going to substitute in this formula theta equals pi over 3. However, before we do the substitution, let's simplify this statement. So dy over dx, which represents the slope, is equal to, okay? So I have here sine and sine, so minus 2 sine squared theta. Distribute this cosine over the parentheses, plus cosine theta plus 2 cosine squared theta. This is our numerator. Now in the denominator, we have minus 2 sine cosine, and then distribute this sine over the parentheses, and you get minus sine minus 2 sine cosine. Okay, let's continue to simplify this. In the numerator, I'm going to factor out the 2 from the cosine squared and the sine squared. So we get under the parentheses of 2 cosine squared minus sine squared. Okay, and what's left is cosine theta. In the denominator, we can group these two negative 2 sine theta cosine theta and get negative 4 sine theta cosine theta minus sine theta. Okay, now I will simplify this more using some trigonometric identities. So in the numerator, the parenthesis is equal to cosine 2 theta. Now, in the denominator, if we write this 4 as negative 2 times 2, then 2 sine theta cosine theta will give us sine 2 theta. So the negative 4 times sine theta cosine theta can be written as -2 sine of 2 theta. So using these trigonometric identities, let's rewrite our slope formula. So we have 2 cosine 2 theta plus cosine theta in the numerator, and -2 sine 2 theta minus sine theta in the denominator. Okay, now our statement is simple enough, so we can substitute our parameter theta equals pi over 3 in the formula. So we get 2 times cosine 2 pi over 3 plus cosine of pi over 3 all over -2 sine 2 pi over 3 minus sine pi over 3. So cosine 2 pi over 3 is -1 over 2. 2 times -1 over 2. Cosine at pi over 3 is 1 over 2. In the denominator, we have -2 times sine 2 pi over 3 is square root of 3 over 2. And sine pi over 3 is also square root of 3 over 2. So all this simplifies to -1 plus 1 over 2. So -1 over 2 in the numerator, and -3 square root of 3 over 2 in the denominator. And this here can be written as 1 over 3 square root of